Algebra 1, Section 3.1, two-step equations. Before we get into two-step equations, just want to quickly address one-step equations. And basically what you need to do, and I'm going to say this often, both on videos and in class during this chapter and really probably the next one also, and then really periodically throughout the book. I'm going to say this sort of thing. Ask yourself what's happening to the variable and then undo things in reverse order. Now, in reverse order, I'm referring to push Eddie Murphy down a staircase. Please excuse my dear Aunt Sally. That's the reverse order I'm speaking of. So as I look at this first one, x is being added to 2. We're going to subtract 2. That would be the only thing that's happening to x in this one-step equation. So you're going to subtract 2 from both sides. And then your solution then would be x on the left equals, you want to keep that in line, and 3 minus 2 is 1. Quickly also, when you get a solution to an equation, you can always check that by plugging it back in. So if I think x is equal to 1, well, it better be the case that 1 plus 2 is equal to 3, and it is. If it's subtraction, the opposite operation is to add. Ask yourself what's happening to the variable, and then undo that. The undo operation for subtraction is addition. And this then would be y is 107. And again, you can check that because 107 minus 7 equals 100. A lot of times books and teachers will require you to show a check. I'm not really big on that. You can if you want, and I'm not saying I'll never ask for that, but really it's as simple as I just did it. By speaking it. And even into the two-step and multi-step equations, usually your student with pretty good math number sense can do it without really having to write down the check, that is. Okay, here a is being multiplied by 8. You know that? This is multiplication. I think we talked in previous videos that, and also in class I believe, that we're going to get rid of the times symbol. We're not using that anymore, the x for the times. But rather we're going to use the times dot or something just like this. When something's next to a variable or in front of parentheses, we assume that is multiplication. This is 8 times a is equal to 4. What we want to do then is undo the multiplication by dividing. The 8s would cancel here. And you would be left with 4 8s. I do require fractions to be reduced. 4 8s reduces to 1/2. And again, back to the original, isn't it the case that 8 times 1/2 does equal 4? So it checks. And one more quickly, if our variable is being divided by 9, then what we want to do is multiply by 9. Multiply both sides by 9. And in this case, the 9s would cancel. F is by itself. 0 times 9 is 0. You multiply both sides by 9, and it's still 0. Here's why. 0 ninths is equal to 0. I plug 0 in for F. 0 ninths is a perfectly fine fraction. It's like you cut a pizza into 9 pieces, and then you ate 0 of them. Right? You ate 0 ninths of the pizza. F equals 0 is a fine answer. Okay, and that takes us then to really what is more pertinent to the saying. Ask yourself what's happening to the variable, and then undo things in reverse order. So x, this is a two-step equation now. This is what section 3.1 is about. X is being multiplied by 6 and then subtracted by 5, not the other way around. By orders of operation, multiplication happens before subtraction. So x is being multiplied by 6 and then subtracted by 5. So to undo this, we want to add 5 to both sides. An equal sign is like the fulcrum on a teeter-totter or a seesaw. I don't know what you called it. I called them both of those things. And if two people weigh the same and they're the same distance away from the fulcrum, they can balance on that teeter-totter. And it's the same thing with an equation. If I take something, if for whatever reason someone added 5 pounds on their side of the teeter-totter, the other side would have to add 5 pounds as well, and then they could still balance. It's the same thing with equations. I'm adding 5 to both sides. That means that the left is still equal to the right. So here you have 6x is equal to 24, and then we can divide by 6. That's the other thing that's happening to the variable. And you have x equals 24/6, which is 4. X equals 4. And then let's just do this again. You can do this mentally if you can. 6 times 4 is 24, minus 5 is 19. This is the solution because it checks. Okay? Now that takes us to another similar problem like this. Ask yourself what's happening to the variable and then undo things in reverse order. Y is being divided by 3 and then added to 5. So we want to undo things in reverse order by first subtracting 5, which would bring you to 8 on the left and just y thirds on the right. We've talked before too that a fraction bar means division, right? So y is being divided by 3. We're going to multiply both sides by 3. And you're going to have y by itself on the right. 3 times 8 is 24 on the left. I do very much prefer the variable to come first. So take just an extra line and an extra 3 or 4 seconds to flip that around. Y equals 24. Let's check it. 24 third. Here, I mentioned you could show a check. Let's just write one down. I don't really require this, but you're welcome to do it. You can do it mentally, or you can do what I'm doing here. I like to put an equal sign. If I do write it down, I like to put a question mark over the equal sign, like I'm wondering if this is true. 24 thirds is 8, plus 5 is 13. It checks. Okay, 2 more quick examples that are really application. Look how much work they show for check. I mean, do you need to show all this? I think that's kind of crazy. Do what you think is best, though. It's worth checking, especially on the test, of course. This says a music store sells a used guitar for $120. This is 25 more than half the cost of a new guitar of the same brand. What is the cost of the new guitar? Okay, so now we need to write an equation based on this situation, and then we'll solve our own equation. Okay, so this cost, this 120, it's 25 more than half the cost of a new guitar. So if the cost of a new guitar is X, or N for new, or G for guitar, let's do G. Well, while I'm modeling good behavior for you, I might as well use G for guitar. Or N, yeah, maybe N would even be that. I'm going with G. Half of G plus 25 is equal to 120. Let's just read again and make sure that's what it said. 25 more than half the cost of a new guitar is what this is, and this is the 120, right? So 25 more than half the cost of a new guitar, that's equal to 120. I could see asking a question like this on the test and having a separate line for what the equation is. So this would be worth a point. And then the solution would be down below, because we are going to solve this now. You would subtract 25 from both sides. That would leave you with 1/2 G is equal to 95. And careful here, it's real easy to cut it in half rather than multiply by 2. G is being multiplied by 1/2. You want to multiply that by 2. Some people would say divide by 1/2, but remember, divide means multiply by the reciprocal of. So divide by 1/2 really means multiply by 2. To undo this, we're multiplying by 2. This would be $190. The guitar is $190. Now let's just check that even back into the situation. $190 for a new guitar. This is half the cost of a new guitar, 25 more than half the cost of a new guitar. So $190 cut in half would be 95 plus 25. 95 plus 25 is 120. Now you could check that number back into your equation. You can even check it into the example. All right, last one. The guitar costs $190. Last one. You order iris bulbs from a catalog. Iris bulbs cost 90 cents each. The shipping charge is $2.50. If you have $18.50 to spend, how many iris bulbs can you order? Okay, so the $2.50 is a flat fee. Now I'm just going to convert everything to decimal. So 90 cents to me is $0.9 as it were. $2.5 is the cost for shipping, and you have $18.5 to spend. So that looks like this: 0.9 for each bulb, B for bulb, plus 2.5 flat rate shipping is equal to $18.50, or 18.5. Oh, I don't need the zero. Okay, and then subtract 2.5 from both sides. Undo what's happening to the variable in reverse order. Subtracting 2.5 from both sides would give me 16. And then we need to divide both sides by 0.9, or you might say multiply by the reciprocal of 9/10, which is 10/9. I like words like that, but probably most people with decimal would say divide by 0.9. You'll use your calculator. I'm using my calculator right now. And it comes out to 17.7 repeten. B is 17.7777777 forever. You probably have seen this before in a previous course. You should just put a bar over that digit or digits that are repeating. Here it's just a continuous sevens. So answer the question. How many bulbs can you order? Would you round up and say 18? Better not. This would not be a situation where you would round up. Yes, 17.7 does round up to 18, but you don't have enough money for that 18th bulb. It's actually 17 bulbs. You have enough money to get part of the way of that part of that 18th bulb, but not enough to get all of it. So you can buy 17 bulbs. All right, thanks for tuning in.